Hello everyone, we have a new circuits here and welcome to my channel. We have here a Mosfet fan circuit. When you push the button, the fan is turning on. Also we have here a touch switch using IRFZ44N. We have a circuit here, Mosfet IRFZ44N fan circuit, and this is our circuit diagram. We have the Mosfet here, so as here, and we have the fan, that is a CPU fan case, 12 volts. We have the power supply, 12 volts, and we have an LED power on standby, this one. Also in here we have the push button, and we have this LED blue switch, LED switch on. In here we have the features of the Mosfet. We're going to use Mosfet as a switch. So in here we have this fan. We're going to operate this Mosfet in ohmic region, or as in BJT, that is in saturation mode, but in Mosfet it is called ohmic region. And the drain here, drain terminal of the Mosfet is capable of handling 55 volts. We are only using 12 volts CPU fan here, and we have a gate here of the Mosfet which is capable of driving 20 volts. In here, when you push the switch, just like this, current flows into the resistor RD2. At the same time, LED lights on, lighting on. The voltage here is equivalent to 12 volts, while the gate voltage rating is about 20 volts, so it's okay. This Mosfet is a voltage driven component. Unlike the BJT, which is current driven, the Mosfet is a voltage driven component. And we have the source connected to the ground. So when you close the circuit, only the LED is lighting on, turning on. This green one. In here, there's no current flows yet because the push button is open. Once you push the button, fan is turning on. So in here, I think the current rating of this fan is around 300 milliampere, and it goes here to the drain, to the source. Since this is 12 volts and the drain is capable of handling 55 volts, up to 55 volts here. And we have this called gate threshold voltage. That gate threshold voltage is the minimum amount of the voltage necessary to conduct this Mosfet, which is around 2, 3, up to 4 volts. The minimum voltage requirement for this Mosfet is around 4 volts to turn on this component. And we use this Mosfet as a switch, making this Mosfet to operate in ohmic region or in linear mode. Just like in BJT transistor saturation mode. It can only be you can only activate this component by pushing the switch here, producing a current here and a voltage here, which is equivalent to 12 volts. So the voltage here at the resistor is equal to the 12 volts, making this gate to source to conduct in ohmic region or in linear region as a switch. As you have seen here, we have the resistor here. The purpose of the resistor here is to prevent this capacitance develop at the source to gate. If you don't have the resistor here, uh, the fan will automatically turning on, just like in the case of this my previous project, which is a transistor Mosfet as a touch switch. When you touch the terminal here, it's on, up. But the problem with the circuit is this capacitance developed in the source to gate, to drain, around here, making the LED to turn on. You need a resistor here, pull the resistor to eliminate that capacitance. So what happened here is the LED is always turning on. So in our circuit, aside from the LED is acting as a switch on, every time you push the button, the LED turns on. At the same time, it prevents from this MOSFET to produce a capacitance around the terminal source to gate to drain, making this fan to turn on. So in here, we didn't see any capacitance develop in the circuit unless you push the button here. And I'm using this CPU fan case. It's actually it has an LED, built-in LED in the fan itself. The color blue LED inside the CPU fan case. Around here in our circuit, we need to calculate the value of the resistor of the LED here to protect the LED here and also here, since we're using 12 volt supply. So we're just using KBL here, voltage the drain minus voltage drop across the resistor, the diode equals 0, KBL. We get 10 volts, Ohm's law, using Ohm's law, 500 ohms. The same computation around here. So we get this value 500 ohms and also 500 ohms in this LED. So that is the function of Mosfet as a switch. The fan will turn on upon pushing the switch, producing a voltage here. This is a voltage driven component around this resistor. If you don't have resistor here and you connect directly the switch to the gate, when you push the switch, it will continue running the fan. So you need this resistor, pull down resistor to turn on the power. At least a resistor here, any value, could be 50 ohms up to 1 mega ohms, or sometimes they use YouTubers use 10 kilo ohms. 1 kilo ohms also okay, as long as there is a resistor here to prevent the capacitance to develop in the Mosfet. This is IRFZ44N, and we already have this layout. We have the fan here, the Mosfet, the LED resistor, LED, and the switch, and this is the header. As you have seen here, we have the header here. See that there's a header here. I made a design for the header here. It's just like there's a positive here, negative. That's for the power supply, and these two, the other two, is for the fan, connection of the fan. This one, or you can, if you want to disconnect the fan, and you can also put new load, not only the CPU fan here, but also any kind of load. Could be LED or anything. So we successfully operate the Mosfet in ohmic region, and it's turning on. That is the use of Mosfet as a switch. Mosfet cannot operate unless there is a gate voltage here. Gate voltage, not current. Should be the gate voltage here. Gate to source voltage. Of at least 4 volts. That is the gate threshold voltage of the Mosfet. Okay, thank you for watching the video. Bye bye.